Alright, so we're trying to find tangent at point A. Okay, so we're finding tangent of this, of point A. So we're looking at our first formula here. And we're going to do this, and we'll number these. This is our first formula and our second formula. And what I can do, actually, okay, so because we're looking at x as approaches A, we're looking at this formula here, so we're going to bring it over. So this is the formula we're going to be working with, the limit of x as it approaches A. Okay. So in other words, we're using the first function here, and we're plugging in for here, and then we're using the same function with A replacing the x's, which is exactly what you have done. So we have, in brackets, x squared plus x plus 1 subtracting a squared plus a plus 1, and then this is all divided by exactly the same thing we have in our formula, x minus a. Alright, so we had a good idea of applying this here. Another thing we might be able to do is factor, but we can go through this one way, and if it doesn't seem to work for us, we can try factoring instead. Factoring might not be a bad idea here because it'll split this into probably two sets of numbers here when we go through it, but let's try what you had done here. We had our x squared plus x plus 1 subtract a squared minus a minus 1. You are we all done? Okay. Alright, let's rock it out here. Sorry. So we quickly take a look at the ones. We know the ones are going to cancel each other out, and we're going to group our semi-like terms together. X squared minus a squared plus x minus a divided by still over x over a. Okay? X over a. Put it in bracket because we're going to see what we're going to do here. What we can do here is, if there's anything we can factor, we're going to try to group like terms. Now, when I take a look at this, is there anything I can factor out of x squared and a squared? No. It's technically a difference of squares. Okay. I could do the difference of squares here, but in terms of what I want to do here, I'm actually going to go back and group my a's together and my x's together, okay? Because that way I can actually factor things out. Okay, so what's going to happen is we have x squared plus x minus a squared minus a. Again, still divided by x minus a. And I'm going to group these. I want to factor out of here, and I want to factor out of here. Okay? So the x squared and the x, what can I factor out of that? Yeah, that's right. So we're left with x. And then we have x plus 1. And what can I factor out of the a's? Yeah, let's factor out negative a. So then we're left with a plus 1. Okay, in this case. And we have minus a here. Alright, so sometimes we realize we've gone down the wrong route. We went down this way. It didn't quite help us. We did mention that this was a difference of squares. So we're going to go back a little and work with that idea here. Okay? So this didn't quite take us to where we wanted to go. Now, a difference of squares, if you remember, a difference of squares, so say you had like x squared minus 49. Difference means it's subtracted. It becomes essentially the square root of the first and the last number, or the first and last term. So we have x and 7, and we just add and subtract in the two terms. So in this case, we have x and a. We can square root both those terms. So this is equal to x plus a times x minus a plus x minus a. Okay, and in fact, what I'm going to do is I'm going to group that also together.
It doesn't work out.
This one doesn't?
It doesn't. Instead of cancel it out, you end up getting x plus a, x minus a, and if you substitute x for a, then it doesn't become 2a minus 1.
Okay, let's see. These all factor out. This becomes 1. This becomes x plus a. We get plus 1. When we do it.
Yeah. Wait, it's 2a plus 1.
Yeah, so when we factor these out, this will become a 1. This will also become a 1. So we'll have x plus a times 1 plus 1 divided by technically 1. The ones are, except for the one at the end, they're irrelevant because we multiply this. We have x plus a plus 1. Divided by 1 is irrelevant. We replace x with a. So this is where x becomes a. And we end up at a plus 1. 2a plus 1 is our answer to this question. Does that make sense? Okay, so in this question, they then ask us after for the coordinate of when x equals certain numbers. So when x is -1, okay? In our instance, when x is -1. Well, first of all, we need to find out what that coordinate is. What is the y value of that number? We have a point, -1 is x. We don't know what the y value is. So we take the original equation, which is y is equal to x squared plus x plus 1. Is that what it is? Yeah. And, you know, just like in grade 9, we replace our x's with -1. Okay. So we get -1 squared is 1, plus -1 is -1 plus 1. Our y value is 1 in this case. Does that make sense? Okay, so I have my coordinate now. The slope we had from the original, after we derived it, was 2a plus 1, or in this case, 2x plus 1, right? So our slope is equal to 2x plus 1. They're asking us to find the slope of this line. Well, we do know slope is equal to y2 minus y1 divided by x2 minus x1. So we take this slope. Sorry, I'm going to put it over here again too. Think of this like two equations. y2 minus y1, x2 minus x1. Okay. We're going to replace our slope here with the actual slope value we have, 2x plus 1. Is equal to y2 minus y1 divided by x2 minus x1. We have our coordinate. We have an x and a y value. So we can plug it in for either of them. It actually doesn't matter. What I'll do is actually I'll plug it in for the second ones, okay? Just so that our x's and y's will be positive right off the bat. So we'll get 2x plus 1 is equal to y minus 1 divided by x. Now it's x subtract -1, okay? Subtract -1, which obviously is going to be plus 1, right? Now I'll make that change when I do the next step here. I'm going to move this to the other side of the equation. We move it to the other side of the equation. We're going to get x plus 1 times 2x plus 1. So x plus 1 times 2x plus 1 is equal to y minus 1. Okay? Now that we have that, we're going to FOIL. So we FOIL everything out here. We get 2x squared plus x plus 2x plus 1 is equal to y minus 1. Okay. We're going to bring that 1 over, so we get 2x squared plus 3x plus 2. We move that 1 over, it comes positive, right? Is equal to y. Now we're looking for this coordinate when x is equal to -1. We're looking for the slope of this, right? So again, we're going to now, once we've done this and we've set it all up, we're going to replace our x's with -1. We're looking at it at that point. So we get 2 -1 squared plus 3 -1 plus 2. Let's just move this. Equal to y. We get 2 minus 3 plus 2 equals y. Is that going to work? No. It's not going to work. So, I'm not sure if my adding was where I mixed up. 4 plus 2 is 4 plus 2. 2 plus 2 is 4. Minus 3 is y. Y equals 1, which is what they were looking for. So slope of this at that point is 1. We're trying the other version. When x is approaching 1, we plug it into our formula, our first formula here. F at x subtract f at 1 divided by x minus 1, because our a value is 1. Plug in the equations. We've kind of worked them out to this point here. At this point here, we're going to be factoring that number. So x squared plus x minus 2. X and x needs to add up to positive 1x. Our options are 2 and 1. One of these will be negative. So if the 1's negative, we get negative x and 2x, which will work out. So these are our columns. We get x minus 1 and x plus 2. So we factor the top of this equation to get x minus 1 times x plus 2 divided by x minus 1. Okay. These two guys cancel out. X plus 2. We're looking at this when x is approaching 1, correct? So it's when x is approaching 1, x becomes 1, we get 3. You what their answer was? Yeah. So, this one actually took us probably less time than the other version. Both versions worked in terms of solving this.
Mm-hmm.
Okay. Both of those worked. This version might have been the easier of the two in this case. All right, in question 11, they're asking us to find the points of intersection between these two parabolas. Y is equal to 1/2 x squared, and y is equal to 1 minus 1/2 x squared. Okay, so these two parabolas here. Point of intersection is essentially when these two guys are going to cross each other. Okay, so we're going to use a substitution method to try to solve this right off the bat. Y is equal to that. Y is equal to that. So I'm going to I'm going to replace y with that value in the first one. So our equation 1 and our equation 2. I'm going to replace this value from equation 1 into equation 2. So we get 1/2 x squared is equal to 1 subtract 1/2 x squared. Okay. When I move that half over, I get 1/2 x squared plus 1/2 x squared is equal to 1. A half x squared plus a half x squared, do you know what it's going to be?
1.
Yep.
X squared.
1x squared or x squared. And the square root of this, x is going to be plus or minus 1. So that's our value for x. Okay? So it's going to cross at plus or minus 1. These are both parabolas heading upwards. So if we were kind of to graph it, all right. This one's a parabola heading downwards. Yeah, so it's going to have 2 points of intersection. Okay, if you think of it, just a quick point, it's going to look something like this. Okay, this parabola is going to be a half, so it's heading upwards like that. The other parabola is something like that. Okay, so it's going to have 2 points of intersection. So what this is telling us, that the points of intersection are in fact, let's say this is just kind of where we're going here. One of them is going to be at -1 on the x-axis, and one of them is going to be at +1, is what it's telling us. Okay, we have to find the two y values. So we take this x and plug it into either equation. It doesn't matter because they're crossing there, so we're going to find it. I'm going to plug it into the first equation because that looks like the easier of the two. Okay, so we have y is equal to 1/2 x squared. And we're going to do it twice because we have to do it for positive and -1. So we get y is equal to 1/2 1 squared. Are they going to be the same point? The y value?
Yeah.
Yeah, they're going to be the same y value. Y is going to be a half. Y is going to be a half.
That's right answer.
Yeah. So your two coordinates where they cross each other are x at -1.5 and x at 1.5. Those are the two coordinates.
Why is plus and minus 1?
Because when you square root a number, technically +1 times +1 is +1, and -1 times -1 is +1. There's two options there, right? So we have to exhaust both options. Okay, so we're going to use the second method here to prove what we've just done, where those two perpendicular, or where those two parabolas cross each other. We need to find tangent lines. So we're going to find the limit as h approaches 0. So in this formula, we get, and remember our original equation is y is equal to a half x squared, right? So we have f at a plus h minus f at a divided by h. Okay, so we put our function into use here. The function is 1/2, and in this case we do a plus h squared minus function at a, so it's 1/2 a squared, all divided by just the letter h. Okay, now I'm going to FOIL what we have here in this bracket. And quickly, I'm going to tell you what that is in my head. Because that's a perfect square trinomial, I think that's what they call it. It becomes a squared plus 2ah plus h squared. Okay, does that make sense in terms of the FOIL? Subtract it 1 over 2a squared, everything divided by h. Okay, I'm going to distribute the half. So I get 1/2 a squared plus ah, because 2 times a half is 1, ah, plus 1/2 h squared minus a half a squared divided by h. Okay. Quickly looking at this, the positive a squared and the negative a squared are going to cancel each other out. And I'm just going to rearrange the order here. We're going to have a half h squared plus a h divided by h. Divided by h. Oh, and, sorry, side note. Remember, this is at the point of when x is 1, right? We had our two coordinates. What were the two coordinates? X at, oh yeah, 1.5. And the other one was negative 1.5. Those are our two coordinates, right? So, those are points. Now, this can be factored. I'm going to do it in red. Think of this like a half times h divided by h plus, because we could split these. That h means both of those multiplication, both of those parts are divided by h. A times h divided by h, which means I can cancel my h's out. When we look at it this way, it's easy to see that these h's are going to get rid of each other. So we no longer need to be a fraction. We just have 1/2 h plus a. Now, as h is approaching 0, we plug it in for h, and we get just a. And our a value was when x was 1, right? We had one of them when x was 1. We would plug it in, so the limit would be a slope of 1. It's going in the positive direction. And the other option, so we'll split this into 2, because remember we had two options, equaled a. Other options when x was negative 1. So in that case, we'd have negative 1. So these are perpendicular to each other in terms of their slopes, right? That's at one of the lines. We have a positive slope of 1, and a negative slope of 1 is going to be two perpendicular lines. I may not have drawn them perfectly, but it's going to be two perpendicular lines in terms of their slopes, positive 1 and negative 1. We've proven it through the very first equation. We can technically prove it through the second equation too. It's just a little more complex, that's all. So when we're replacing our numbers, just remember this is the second function we were supposed to prove it with. When we're using this, whatever x value there is, the variable, we just replace it with a plus h. So I put this function in the first set here, and I replaced the x with a plus h. And the second function, I just replaced it with the letter a.
So you only do that when you just have an equation, right?
Yeah.
But if they give you points.
Now, the points are important because they help us find, you'll need an equation or some slope to work with. So they've given us an original equation. We need that. If they just given you points, you probably have to find the equation and then put the equation into this. Okay, because they're looking for the full function. And what we'll do is we'll go through this to prove it in the end here. This one's a little more complex, as you can see. Still same multiplication as we had before. We know that this is going to be a squared plus 2ah plus h squared plus 1. This one's going to be more complex, as you see as we go through it. But we would have to technically prove it too. Subtracted by, I don't have room here. There we go. Oh no, don't go too far. Just there we go. And then in this function here, right, we're slowly working them out. Negative a half. Oh, it's just a squared minus 1. Okay, so that one worked out nice. A squared minus 1. We didn't have to square it. Divided by h. I'm going to try and go through this a little quicker. We apply that negative a half, so we get negative a half a squared minus ah minus negative a half h squared plus 1. And then we apply to the other one. Again, subtracted by, you know what we'll do? Forget it, subtracted by, we'll actually apply that negative so we can drop these brackets. So it's going to become plus a half a squared plus 1. Okay? All divided by h. We would collect like terms here. I'm going to tell you this positive and this negative guy are going to go. We're going to get 2 though over here because when we add those numbers together, we'll get 2. So we get, and we'll rearrange this so we get negative 1 half h squared minus ah minus
why it becomes like positive 1 at the right?
Because we applied this negative to both.
Mm-hmm.
Just want to make sure I put the right number in here because I think those ones should have gone away. Is it plus 1 in the equation? Because I put negative 1 in here. That's my fault. This should have been plus 1. Yeah.
I was thinking.
Yeah, so I knew something wasn't working out there. So then that should become a negative when I apply it. I knew we made a mistake somewhere there. So sorry, then the ones will also cancel each other out. Positive and negative. Okay. And then divided by h. And then we're right back to where we were before, if you remember. It's pretty much the same question, but this time we have negative a half h minus a. Okay. As h approaches 0, just drops it off, so we have negative a. And the only difference here is the slopes again, right? We're looking at x when it was 1 and x when it was negative 1. So we're just going to have the opposite effect. Negative 1 and positive 1 still perpendicular. Does that make sense?